Alright, so this video kind of has two purposes. One purpose is to talk about complementary angles in regards to trig functions, and the other is to be able to find a trig function when given another ratio. So if I know the cosine of x, can I find the sine of x? So I'm going to start there. So I'm going to go ahead and draw a triangle so I can kind of see these relationships that I'm talking about. So if I have a right triangle, and I'll pick an angle to be x, so we'll say this angle is x. So the cosine of x, so cosine, and I'll go ahead and put our mnemonic up here to remind us, cosine is adjacent over hypotenuse. So if I look here, if this is 3 over 5, adjacent is 3, and hypotenuse is 5. So in order to find the sine of x, I need the opposite in hypotenuse. So I have the hypotenuse, but I do not have the opposite. So I need to find this side length. So I can do that using the Pythagorean theorem, which says that this side squared plus this side squared equals the hypotenuse squared. So we'll just call this a for convenience sake. And we'll say a squared plus 3 squared equals 5 squared. So then I have a squared plus 3 squared is 9 equals 5 squared, which is 25. So if I'm going to find what a is, I need to get that by itself. So I'm going to minus 9 from both sides. And I have a squared equals 25 minus 9, which is 16. So now, to get this a all by itself, I'm going to take the square root of both sides, and the square root of 16 is 4. So this side length is equal to 4. So now that I have my triangle with all my sides labeled, I can look here, and sine is opposite over hypotenuse, so that would be 4 over 5. So I have sine of x is 4 over 5. So basically, once you draw your triangle, find all your sides, then it's pretty straightforward to find whatever trig function you're looking for. So let's go ahead and try that again. So this is the tangent of x, so we'll call this x. Tangent is opposite, so my opposite is 5, over adjacent, so my adjacent is 12. So this time it's the hypotenuse that I'm missing. So I'm going to go ahead and use that Pythagorean theorem. So I have 5 squared plus 12 squared equals a squared. So then I have 25 plus 144 equals a squared. And 25 plus 144 is 169. So I'm going to take that square root of both sides. And the square root of 169 is 13. So this side length is 13. So sine, if I remind myself with my mnemonic, is opposite over hypotenuse. So sine would be 5 is the opposite, 13 is the hypotenuse, so this would be 5 over 13. So 3 and 4 are very similar. I'm going to go ahead and draw a couple more triangles. So this time I'm given cosine is 6 over 10. So here's my triangle. I have x. Cosine is adjacent over hypotenuse, so the adjacent is 6, the hypotenuse is 10, and I'm missing the opposite side. So I have 6 squared plus a squared equals 10 squared, or 36 plus a squared equals 100. So I'm going to minus that 36 from both sides. And I have a squared equals 100 minus 36, which is 64. So then I'm going to take the square root of this side, the square root of this side, and these cancel, and the square root of 64 is 8. So then the tangent of x is opposite over adjacent. So the opposite is 8, adjacent is 6. And then my last example starts with sine. So I have my triangle and my x. Sine is opposite, so my opposite is 3, over hypotenuse, which is 6. So now I'm looking for the adjacent side so that I can find my cosine. So I have a squared plus 3 squared equals 6 squared, or a squared plus 9 equals 36. I'm going to go ahead and minus 9 from both sides, and I have a squared equals 27. So this time when I take the square root of both sides, the square root of 27 doesn't simplify all nicely like the other three did. So I'm actually going to leave it just like that. A is equal to the square root of 27. So then when I find my cosine, cosine is adjacent, which is the square root of 27, over the hypotenuse, which is 6. So the next section of your notes is talking about complementary angles. So a complementary angles are two angles that add to 90 degrees. So if we think about a right triangle, which is what we've been talking about throughout all of these trigonometry sections, a right triangle has a right angle, obviously. That's why it's called a right triangle. That's 90 degrees. So if you think about the properties of a triangle, the three angles of a triangle always add to 180 degrees. So that means that these two angles, if I do 180 minus 90, that's equal to 90. So these two angles have to add to 90 so that all three angles add to 180. So your two acute angles in a right triangle are complementary every time. So one cool thing that this does when we are talking about trig functions is that sine and cosine become what we call co-functions, meaning that the sine of one angle is equal to the cosine of that angle's complement, and vice versa. So I think that's easier to understand with an example. So if we look at this example right here, the sine of 30 is equal to the cosine of 60. So these two angles add to 90, they're complementary. The sine of one is equal to the cosine of another. Or if I have the cosine of 42, well, the complement of 42, if I do 90 minus 42, is 48. So the cosine of 42 is equal to the sine of 48. So all of these examples, we're going to use that idea to rewrite each equation using their complements and the other trig function. So the complement of 8 is 90 minus 8, which is 82. And then the co-function, the other trig function of cosine, is sine. So the cosine of 8 is equal to the sine of 82. Versus number 6, if I do 90 minus 47, I'm left with 43 degrees. And the other trig function of sine is cosine. So the sine of 47 is equal to the cosine of 43. And you could plug both of these into your calculator and you really would get the same thing. The sine of 47, the cosine of 43 would give you the same answer. So then number 7 becomes the cosine of 89. 8 becomes the sine of 57. 9 becomes the cosine of 77. And then 10 is a little bit interesting because I don't know what x is, but I do know that this is going to become the cosine of whatever 90 minus x is, because that would be the complement of this degree.